sphere? As the electric field is present inside as well as outside, no? So first we'll do one thing. The electric field present, the lines of force, I'll draw it. So what is the field? Electric field is present inside as well as outside. What is the electric field outside? E out. And the electric field will be there inside also. E in. So what we have to do? I'll assume an elemental tin shell outside. Then I'll integrate from capital R to infinity. I'll get the energy present outside. It is similar to like a conducting shell. Am I right? For your convenience, I'll show both the things so that will be easy for you. So I'm going to draw again an elemental shell. Let me draw part-wise. So what is the field outside? Outside it is equal to how much? E out. So at additions are thickness dr, and where the radius will be how much? Small r. So again the same method. So what is the energy present outside? Du 1, I'll write it. Let it be. That should be equal to what should be the energy density formula? Energy density UD1 into volume of that 4 pi r square dr. What is UD1? Of epsilon naught E out whole square into 4 pi r square dr. If I integrate this capital R to infinity, so this is similar to kq square by 2r only. Am I right? The same formula. For uniformly charged sphere or conducting shell, what is the field outside? Kq by r square. Now, what is E out formula? What about E in formula? Kq by r cube. Hope if you can remember. Today we have derived in the first session. Okay, this is what field energy present outside the sphere. I'll put it everything here. Yeah, field energy outside the sphere. Now, similarly, I want field energy inside the sphere. So for that, what shall I do? Yes, okay, assume one more. I think that one. So here I ask you to assume here. Why it is not showing some color I need? Oh. Okay, assume one more thin shell. So let the radius of this be x. Let me write because r smaller I took already. Let the thickness be dx. The field here, let it be E2 or E out or E in. How much of energy present in this one? So du2 is equal to energy density at that point into 4 pi x square dx. I'll write x here. This be more. Now look at carefully things. So I think this we have to derive. There is no other way. Of epsilon naught in square 4 pi x square dx. What is the electric field inside? Kqx by r cube whole square 4 pi x square dx. So 4 pi epsilon naught k square q square by 2 r to power of 6 x to power of 4 dx. Let me integrate this. So du2 4 pi epsilon naught k square 1 cancel out. So k q square by 2 r to power of 6 you keep outside. Anybody limit? What should be the limit? 0 to capital R, because we are calculating the field inside. We're calculating field, how much of energy present inside, no? So 0 to capital R, it should be. Okay, solving this will end up with U2 is equal to KQ square 2 R to power of 6. This will become R to power of 5 by 5. Final answer, KQ square by 10 R. Total energy, total self energy, or the self energy of a uniformly charged sphere. Equal to U1 plus U2. Now what is U1? KQ square by 2R. KQ square by 10R. How much will get this? 3 KQ square by 5R. Better to remember formulas. The self energy of uniformly charged sphere is how much? 3 KQ square by 5R. What all I do, what? Sir, why can't you derive by the work done? This will be very difficult for me to assume that elemental structure all. So using energy density, we're able to